Hi everyone, good morning. My name is Raoni. I am an international student, studying computer programming analysis at George Brown College. And today I will explain you my assignment number 3 of machine learning, Comp 3132. I will save time and go straight to the questions we have to answer in this assignment, okay? The questions are from 1 to 10. For some questions, which can choose one of the three methods. Let's go ahead. Import necessary packages libraries. Get the image from the URL. Visualize the content of the response. Generate the run. Plot the resulting image from the array. Print the array shape. Compare the values of color channels 0 and 1 and 1 and 2. Save the color channel. Visualize the values inside the resulting array. Create a path array. Compare both arrays. Apply the kernel. Plot the resulting array. Define a function to squash out the values between 0 to 255 range, and define a function to apply. Create a kernel to detect horizontal lines. Now, 1A, based on the kernels represented the above image, create a kernel to detect 45 degrees line using convolution. Apply to the card image and plot the results. In this segment, we are diving into fascinating aspect of imaging process, detecting 45 degrees line in an image using convolution operations. First, we introduce the concept of kernel, a fundamental tool here. In image processing using to highlight the specific factors in images. In 1B, based on the kernels represented of the above images, create a kernel to detect 135 degrees line using convolution. Apply the card image and plot the results. And the code segment aims the highlight 135 degrees lines in the image through a convolution operations. This kernel is structured to emphasize factors at 135 degrees operation with positive values targeting the desired angle and negative values suppressing irrelated factors. The questions number 2, apply the following kernels to your image and plot output. To detect that in an image, the code employs a specific kernel and convolution. Step 1, define the kernel. A kernel for edge detection is created as follows. This kernel is designed to highlight edges by contrasting adjacent pixels horizontally and vertically. Apply the kernel and visualize the results here. The second B, the code detects edges using a specific kernel. Target edges with a focus on pixel contrast. Applies the kernel highlighted edges for visualization. That was good. 2C. The code performs edge detections with a different kernel, designed for sharp edge highlighting, and applies kernel visualization edges clearly. Now, the part B is more delayed because uh, we have run a lot of things here. The first, import the necessary packages and the library, load the dataset, one hot encode target values, convert from integers to floats, and normalize the range 0 to 1. Now create the model. This snap outlines the creations of a convolutional neural network CNN models using Keras, a popular deep learning library in Python. On the model compilation, display a summary model, sequential 5. Create a custom callback class to the called during the training. This code snap defines a custom callback class that stands tf.keras.callbacks.callback from TensorFlow, designed to perform specific actions at various stages of the training process. Institute the custom callback. And now to train the network with the train images and train labels. 0, 5, 10, 5 to 5. Just a second. Each box reply 5 to 5, 0, 5, 10, 50. The next 20. $25, $30, $35, when I use custom callback in your model training, you instantiate an object of this class and pass it to the callback parameter of the model.fit method. This way, the callback actions are executed according to its definitions during the model's training process. Here, define a function to plot the results. Call the results plotting function. Accuracy curves. Training and validation accuracy. Now, the number 3, did the network present signings of overfitting? If so, in which epoch? This is my answer. Number 4, write down how many layers this model has identified the types. My answer here. And briefly explain what's the purpose of each of those layers here. In number 6, this code snap demonstrates how to enhance a convolutional neural network model by adding more convolutional layers, compiling the new model, training it with a dataset, and then visualizing and the training results. Add more or one or more convolutions layers to our model and run it again. Jesus Christ. Go, go, go. 05. It go it goes from 5 to 5 again. 05, then 15, 20, 25, and so on. Jesus Christ. Yeah, T4 room. 20, 25. Go, go, go. In number 7, compare the results and describe what are the difference between them. My answer here. Number 8, add a drop layer to your model, run it, and compare the result with the previous one. Adding a dropout layer to the model introduces a technique to prevent overfitting by randomly setting a fractional of the input units to 0 at each update during training time, which in this case it's set to 50%. Mm, just a second. Oh, smart. I have so much. The number 10, explain with your own words what is the purpose of the dropout layers and how it works. Here my answer. And number 10, make any other modification in the hyper parameters to improve the model's accuracy and compare the final results with the previous one. This step involves tweaking two models' hyperparameters to potentially enhance its accuracy. The changes made include adjustments to the optimizer learning rate and the training buffer size. Again, just a second. I'm so sorry. I'm going to cut the video so it doesn't get to be so big. Thanks so much and have a good one. Bye.